Select the best reagent or series of reagents to accomplish the following transformation. So we want to take a look at our starting material and our product to see what has changed. So we can see a secondary alcohol here and an aldehyde. And if we look at our product, then we see that the secondary alcohol, the one I labeled over here, doesn't appear to have changed at all. And we have another secondary alcohol. And if you just look at this really quickly, what might not be immediately apparent is that we've also changed the carbon skeleton. So I think we can clearly see the cyclohexane ring in both. If you look at the starting material, you have just one other carbon atom attached to the cyclohexane. And if we look at the product, we have 1, 2. So we have added a methyl group. So what we have done in this reaction is we have added a methyl group to the aldehyde. And so we know that aldehyde carbon is electrophilic, so we need a nucleophilic carbon. So we should be thinking something along the lines of an organometallic reagent. So maybe something like methyl magnesium bromide, right? Because we could add that to the aldehyde and we would be able to get that secondary alcohol. We do need to look closely at this structure though. A Grignard reagent like that is a strong base. So if we were to take the Grignard reagent and simply react it here with this starting material, here's what would happen. So if you had a Grignard reagent and you have an alcohol, what you've got when you have an alcohol is you have an acidic hydrogen. So your Grignard reagent would simply remove that acidic hydrogen. And so when it does so, then you no longer have a Grignard reagent. So, because if you look at what you're forming here, you are forming the alkoxide. Okay, so that's by removing that hydrogen. You've still got your aldehyde. And then you have formed ethane. Okay, and your Grignard reagent is no more. So this means that we need to protect our alcohol. We can't have that acidic hydrogen. So what your textbook shows you is one of many ways to protect an alcohol. It's not our job to learn every single possibility. We're going to focus on a couple very common ones. And so what your textbook shows you is that it's possible to protect an alcohol as a silyl ether. So if you have an alcohol, you can react it with something like this reagent. So I'm going to go ahead and just circle this as the right answer, and then we'll run through it and explain why. So this silicon group, so it looks really awkward the way it's drawn there. So let's go ahead and show this structure. So you've got the silicon, it's got a tert-butyl group and 2 methyls. So let's go ahead and draw that tert-butyl group and then 2 methyls. And so that's tert-butyl dimethylsilyl chloride, or TB for tert-butyl, DM for dimethyl, S for silyl chloride. Okay, and so what your alcohol can do is an SN2-like attack on the silicon, which at first glance might look kind of crazy. I mean, this looks really sterically hindered to be doing an SN2 attack, but then you need to remember that silicon is a lot larger than carbon, so it is actually not all that sterically hindered, and this attack is possible. And so what you will get is this, we're almost there, similar to a silyl ether, right? And what imidazole is a base. And so that is a base. I'm just going to draw a B with some electrons that's going to take off this hydrogen. And this gives you your silyl ether, which is a protected alcohol. Oh, so you've got a silicon, you've got 2 methyl groups, and a tert-butyl group. So this is a protected alcohol. All right, so that's what we are doing in this set of conditions we've chosen. So we are protecting that alcohol. So you'd have O and we TBDMS, and then you'd have the aldehyde. And then in your second step, you could have a Grignard reagent that would be able to attack that aldehyde. Right, so here's the key, is to get the Grignard reagent to attack the aldehyde and not that acidic hydrogen. You need to get rid of that acidic hydrogen. And then this hydrolysis step at the end can remove the protecting group, so PG for protecting group, and protonate the alkoxide. So it's possible to remove these silyl ethers with aqueous acid. You might also see a fluoride ion being used. Your textbook shows the use of tert butyl ammonium fluoride. And so that's also a possibility.